Okay, to start then, okay, well, has everyone set up Google Colab so far? If anyone has any trouble with it, let's figure it out right now, since it's the basis for this entire course.
I think we did not set it up.
Okay.
Yes.
Then let's go do that. So going back to those slides, you will start by creating a Google account, like Gmail account, if you don't have one already. And then go to your Google Drive. And in the top left sort of section, you should be able to find a button that says new, and then follow the arrows here to click more and then connect more apps, and then to the Google Suite Marketplace. If anyone has trouble with that right now, let me know. Otherwise, I'll give you all like a minute or two more and then we'll move on.
Yeah, I think we can have a volunteer for this. So the volunteer can, follow all these steps and we can then correct them, like if they're making mistakes. And from these mistakes, others can also learn. I think from the presentation, it will be hard to follow for them. I think according.
But after more, where we need to go to?
Connect
After
more apps.
Suite Marketplace? Oh no, connect more applications and then Suite Marketplace. Okay.
Yes.
It may be easier for me just to Google Colab and then just click on the link. That works too, if this is too complicated.
Okay, we can try that too.
I think this may be easier for people, that's all.
Does it still allow you to create copies in your own Google Drive though?
Yeah, I think Dottie has sent a link, so you can open that link and then create a new notebook. So that's the easiest step to prepare a notebook in Google Colaboratory.
It'll automatically log you into your Gmail account as long as you're logged in.
Yeah.
Oh,
yes.
we're not creating a notebook from scratch.
Oh, that's my bad. Should we put the link to the notebook then and have them make a copy?
We can do that though. Then people will probably we'll run a bunch of code blocks, and we've had issues with that last time. So, but so you guys are saying that people can create copies of a pre-made notebook without having Google Colab, and then okay, we'll just move on to that then.
Wait, no, they need a Gmail account to do all that. They need a Google account to do that. Yeah.
Yes, I understand that we need to install Google Collaboratory. Yes, on Google Drive, from Google Drive.
So
no, we don't have to install it. It's already an online software. You can directly run it.
I mean, let's just go with installing it since it's in the slides, and the reason why it's in the slides is so people can do that process themselves. Like instead of using notebooks other people made all the time, they can make their own notebooks, and doing that through the G Suite application, right? That makes sense with you guys, right?
Yeah, I think
Yeah.
part of it's already created all of this.
Okay. Back to the slides then. So once you've installed Google Colaboratory from the G Suite Market and gone through all the prompts, then you're ready to go, because this stuff right here is just how to make a fresh notebook. In this case, we'll be using a pre-made notebook that will describe the instructions for this laboratory. Okay. Everyone see it?
Yeah.
Okay, good. Okay, so then to start with this laboratory, we'll provide an introduction to using Unix commands within Google Colaboratory's environment. By default, Google Collaborate notebooks will run Python 3, so a different programming language. But in that case, therefore, to use Unix commands instead of Python code, you need to specify that you want to run Unix commands as Unix commands. And one way this can be achieved is by using this right here, %sign bash, where bash itself refers to a type of Unix shell, which is described in the lecture. So the first thing you can do is make a code block with this bash header. It won't run anything because there isn't actually any code, but that is what you'll want as the header for all of your Unix command code blocks. Next, familiar yourself with how Google Colaboratory is structured. You can click on the left-hand corner, there's a folder icon, and it'll open up a side panel, and this is called the content directory, specifically /content, because then if you click on this folder with an arrow here, it'll take you to the root directory, which is just /. And here you can see the folder that we were in, the content directory, right here. So you can think of the structure as a sort of branching graph structure, like here. So at the top, there's the root directory, and then connected to that are multiple subdirectories. For example, there's bin right here, there's etc, there's home directory, which is called home, but Google Colab doesn't treat it as home that much. There's also a user directory here, but what's most important is this content directory, because that is the default folder that Google Colab starts you in every time you create a new notebook. So in fact, this side panel doesn't affect the directory of the notebook itself at all. It's just a sort of graphical user interface for it, whereas the notebook itself is still in the content directory. And you can confirm that by using this first Unix command, print working directory. and it'll output the working directory that you're in the notebook, which is /content. Okay, everyone good so far? Okay, no questions. So as our next Unix command, we'll want to look at what's in the contents of a directory. So we're in the content directory here. In the left panel, we can already see that there's a folder called sample data, but we can verify that with this code, this list command, which Sergey mentioned, will display the contents of the current working directory. You can also investigate this further because sample data is a directory itself, and you can look at what's inside this subdirectory by using the name of that folder, sample data, as what's called a command line argument. So you type ls and then a space, and then your first argument, which would be sample_data. And it shows all the files now in that folder. Okay, then next, let's say we want to change directories. So we want to move into the sample data folder. And the way we'll do that is with the change directory command, cd, and then space, and then the name of the folder again as an argument, sample_data. And then you can confirm that we've moved into that folder with the print working directory command. And you'll see here that it prints out not just that we're in sample data, but also that sample data is a subdirectory of content directory, which in turn is a subdirectory of the root directory. And that's what's known as an absolute path, because it's a representation of the connection from the root directory to the current subdirectory, which is sample data. Note that this won't work if you run change directory and print working directory in different code blocks. That's because each of these code blocks creates a different instance of the bash shell. So if you want to run Unix commands from within a directory that's not the content directory, you will want to change directories first, and then have the commands after that all in the same code block. In contrast, though, if you create or delete any files or directories, they will persist across all code blocks. Okay, so Unix commands for manipulating files. You can create a file with this touch command. And so here we have touch, and then with first command line argument, empty file.txt. And what this will do is it will create an empty file called empty file.txt. And we can verify that it did that with the list command. See here, it shows the file that was just created. And then you can also confirm that this does persist across code blocks by doing the list command in a different code block. So same outputs. Next, you can rename files using this move command.
Sorry, I did not quite get the last command you explained about creating a text file. Where is it created when you?
So when you create it, it creates it in the current working directory, which in this case is the content folder. So
isn't it the empty file? Wait, no.
Yes, it is an empty file. So there's nothing in it, but it'll still exist.
Mm-hmm.
See, I created it right there. And you can confirm that in the output here.
I see.
Yep.
It's created in the current directory. And if you were to go like current directory to drive, you would then in the same block say that you want to touch a new txt file, then it will be created in YouTube drive if you work in the same block.
That is correct.
Okay, thanks.
Okay. Any other questions before we move on? Okay. So continuing on then, aside from creating files with touch, you can also rename files with MV, which is an abbreviation of move. That's because this command can also be used to move files, but for now, we'll just use it to rename them. So for this command, this will take 2 command line arguments. The first one being the name of the file you want to rename, and then the second one being what you want to rename it to. So in this case, we're taking our empty file.txt and renaming it into empty.txt. And when we run this, you can see that instead of empty file.txt up here, we now have empty.txt. You can double check it here in the interface that it was indeed renamed. Additionally, you can also make copies of files using the copy command. And this also takes 2 command line arguments. The first one is the name of the file to copy, and here in this case, empty.txt. And then the next one is the name of the duplicate file. So in this case, we want a copy of empty.txt called empty2.txt. And upon running that, you can see now that there's both empty.txt and empty2.txt within the current directory. So in the interface here, it shows it. In addition, you can also delete files that have been made. You can do this individually by using 1 command line argument at a time, but you can also delete multiple files at once by using multiple command line arguments. In this case, we have the remove command, and then the first file we want to delete, empty.txt, and then the second file we want to delete, empty2.txt. And then upon checking that directory, there's now nothing in it. And if we refresh this, you can see that those 2 files were indeed deleted. Similarly, you can use multiple command line arguments to manipulate several files at once with other Unix commands too, which is something you can experiment in your own time. Okay, so those were commands for manipulating files. Next are commands for manipulating directories. So instead of touch to make a file, we have make directory to make a directory. In this case, we can create a directory called new directory. And here it shows that the directory was made. And here you can see that there's now a new folder icon as well. You can also rename directories with the move command again. So in this case, we're renaming this directory called new directory to project directory. And you can see that the renaming did take place here and also in the interface as well. Next up, you can also copy directories, just like we could copy files. However, in this case, copy takes 2 command line arguments, the directory you want to copy and the name of the duplicate directory. However, just running it as copy and then those 2 arguments will fail. And this is a safety feature built into copy, remove, and some other Unix commands where if you want to use them with directories, you have to specify what's called an option, which is this -R right here. So if you add that -r, it'll then work instead of giving that error right there. Now we have that copy of the directory. What R stands for, it's an abbreviation of the word recursive. So that describes, for example, with remove the deletion of a directory, any subdirectories, any directories within that, and then any directories within that directory. And you can also type it as recursive, like the word itself, and then with double dashes. So that will also work too. In this case here, we ran this and created another copy, which we called project directory 3. So as another command line, our Unix command we can use is to remove directories. And similar to copy, as mentioned before, it does require this R option. And we can also use multiple command line arguments to delete multiple directories at once. So here we have project directory that we want to delete, project directory 2, and project directory 3. So upon running that, you can see that these 3 directories here are now gone. So with these directories that you have here, you can now work on the first assignment.
Wait, one question first.
Oh, sure.
The -r that we had, it's only when working with directories, right?
Yes, in this case.
But there are other cases?
Well, these command line options are often common with other Unix commands, as well as some people have written their own commands. Like, for example, let's say you want to analyze a certain type of data, then someone would have written what's called a command line utility to analyze that, and then they might have a -r option there that does something different.
But when we are working with simple TXT files, we don't need the -r command to be added.
No, you do not.
Okay, thanks.
Yep. Any other questions before we move on to the assignment?
I'm sorry, maybe I missed something at the beginning. Could you please explain once again the general idea? So I see the link, yes, Rem gave us. So we need to access this link, yes, because at first we installed this, how it's called, Collaboratory. So when we access this link, we need to copy, yes, this notebook. And here inside this notebook, we'll have some assignments, yes, that we can, and some codes that we can run and some assignments. So what is our task right now?
So this first section is a sort of tutorial section to review the commands and things you need to know in order to do the assignments.
So we need to do it simultaneously with you?
You do not.
So we can just look at your presentation, yes, and then we need to access this link and yes, because somewhat I think, at least me, as for me, I missed something at the beginning and I do not understand what is my task right now.
I see. We can review that right now, since other people may have missed the same things. But for example, if you have any questions outside of the class, you can either email us TAs or perhaps look for the answer inside this tutorial section.
Okay.
Yep. But yeah, what would you like me to go over again?
I don't know, what about other students? How do they proceed with you? Yes, people, please react. And if you have some questions, please put the questions.
can I ask, because I installed this program Collaborate. Actually, I have on my screen now, I have this bash. What is the next step?
La idee? Da, numai aici la primul etaj n-am știut acolo de unde se închid. La scară. Da, eu încolo am închis.
As in you've done this first step at the beginning, then you can.
Yes, you can. Once again, now I just open this Collaborate, and I wrote this bash, yes, and it appeared. What I should do next?
If you can see each code block, when you highlight your mouse over it, it'll produce this button over here. If you click this button, then it'll run the code in that code block, and output will be printed in this white section down here.
And appear usage error. Bash is a cell magic, but the cell body is empty. What I should do?
That is fine. That means you did that first thing properly. The reason is because that is just a header. It isn't actually a Unix command, but it will tell Google Colab that you want to run anything below that as a Unix command. Because otherwise, if you do not have this header, oftentimes Google Colaboratory will try to run the code that follows it in a language called Python.
Mm-hmm. And also below is a new section.
Which new section?
New section, like is written.
You should share your screen, so it'll be easier to
share my screen. Okay.
Yes, I will stop sharing my screen and let's share your screen. Do you know how to do that?
But host disabled. Just
okay.
I can't share. It's written the host disabled participant screen sharing.
I just changed it right now.
Okay.
You should be able to do it if you try again.
Now we see?
Nope.
Did you click the green button on the bottom that says share screen?
Okay. Now.
Yeah, there you go.
Okay, I have this.
Okay. So go to this link in the chat of Zoom, of the Zoom chat, and open up this link.
To return back in Zoom?
Yes.
It is in the Zoom chat. You have an option at the bottom called chat. You can click.
So I'm sorry for my intrusion. I understand this link gives you, so this is a link to this notebook as an example, yes, but we need to save a copy. Yes, because we cannot run it. Someone can add something and not to spoil everything. That is why, so each student must save a copy of this Jupyter notebook. Yes, I understand correctly.
Yes.
And with this file, we can work at home. Yes, after the classes, quietly. Yes, and to read these explanations. Yes, because it's important. I don't know, for those students who did not understand, they must understand that they must get access this link and save it on the Google Drive. Yes, for that, everybody must have Gmail. A bit complicated. Yes, maybe for someone. Yes. That is why I think it's important. So all the students must understand how to save it on the Google Drive. And for that, each student must have a Gmail. I'm sorry if I say something simple things, but I think it's important. Thank you.
Thank you for your input.
Yes, but why I should write this PWD to display the current directory? Here, this I should type somewhere.
So can you first open a notebook which from the link which is given in the chat, and then you can go into go into that notebook, and then you can access all the commands there.
Juliana, you created a new notebook, so you need to access a sample notebook. Yes, and the link, yes, because you created an empty notebook and you don't need to write any commands. Yes, you need to access the link. This is a sample. Yes, a sample.
Okay.
Because we started with downloading Google Colab, yes, and we started with creating new files, yes, and that is why maybe it was a problem for some students. Okay.
Okay, we will exercise tomorrow from the morning till 7 o'clock in the evening. We will do something, I hope. So, but we can access folders.
Yes.
Okay, do you see the sample notebook in the chat?
Sorry?
The sample notebook that's in the chat. Do you see that link?
This is okay. And the chat, I see Collaboratory search. What, I have to access it?
You just click on it. Just click on it. Just click on that link.
Okay.
And it should take you to the sample notebook. And then from there, we can, that's where you guys make copies. So Cynthia, did we already show how to make a copy of a notebook or no?
It's in the example.
Okay.
So just scroll down. And then,
okay.
Yep.
I will save it. But already it's like saved here. This is like a header. Okay.
Yep. And then as you scroll down, you can press the play button on each code block and it'll run the code. And then you can see what happens.
Okay, thank you. Already something's clear.
Okay, happy to help. Let me know if you have any more questions. That's what we're here for. Okay, so moving on to the assignment, I will share my screen again. So let's see. As your first lab assignment, you'll be creating an organized file structure for your projects. Since to read things here, keeping organized is an important aspect of efficient research. From saving time to preventing confusion with your collaborators, documenting and organizing one's project files is essential for producing transparent and reproducible results. To this end, README files can be used to help users of your research, including yourself in the future when maybe you've forgotten what everything is, to navigate through many files that you produce by providing descriptions for all files and folders stored in its directory. And so today, you'll practice using Unix commands to produce an organized file structure to share the results of your research. As instructions, in a copy of this Colab notebook, use the commands presented in the previous section, so the tutorial section, to replicate the file structure depicted below. It says you'll be graded, but I don't think this course is graded, but when we use it for other things, then it is graded. To start, you can click File on the top of your screen, like right here, and then go down to save a copy in Drive. And that will save a copy of this Google Colab notebook into your own personal Google Drive. Next, you'll want to try and replicate this file structure shown here, where you have a repository directory saved inside the content folder. Here, all the directories that you need to make are colored in blue, and all README files are colored in green. Then there are regular files colored in yellow-orange. These regular files represent like the files you'd have as a result of running your analyses. And additionally, each of these directories is a representation of the kind of data that you'll store in it in a hypothetical project. For example, the summary data directory here will store the outputs of your analyses in tabular format. So .csv files. The notebook directory will contain any notebooks that you used to run different bioinformatic tools to process and analyze your data. Next, there's a figure directory that can be used to store any figures that you want to include in your publication. So to collect them all in one place. Next, there's a multi-panel directory that includes the figures, but combined into a multi-panel figure. So like in journals, if you've ever seen a figure with figure 1.A and 1B and 1C and 1D and 1E and so on, where there's multiple parts to a larger figure. That's where you'd store it in a multi-panel directory. And so to take a step back again, what the task of this assignment is to use what you've learned about creating and moving and copying and deleting files and directories to replicate this structure, where you'd have a repository folder, so a directory to contain everything that has a README file. And you don't have to do anything with the README file, just create a file called README with the touch command. And but in an actual project, it would contain the descriptions of each of these subdirectories, like I described earlier. Then you'd want to make the directories of each of these subdirectories with the make directory command, and then change directories to move into each of these directories one at a time. And then inside each directory, you'd create a README file, as well as these other files, which they can be empty, which is fine, because here we're just trying to get practice producing this kind of file structure. That way, when you share your research with other people, it'll be easy for them to understand what is what. Likewise, if they do the same thing, then you'll easily understand what their different files are, how they created those files, and then be able to potentially replicate that for your own research. So yeah, that's this first assignment. Any questions with it?
Well, when should it be done?
I think just in your own time. We're not grading this, I believe, right? Other TAs?
And
I don't think so.
and who do we send it to? Or direct to whoever? How?
Well, we just do it for ourselves, and we're happy about that.
Yeah, if you'd like your assignment graded, you can
I would
either
like it
email
to be
Sergey
checked,
or us.
just being checked.
Okay.
I do have a question, more complicated one.
Sure.
When when we want to create more like README files in different folders, can we use a for loop in
Yes.
Unix for that, or
Yes.
should we learn to do that? Should we Google that, or should just do like
Well,
manually create each file?
This first assignment is meant to be very simple to gauge like the how much knowledge students have going into the course. But we will cover if statements and for loops tomorrow. But if you want to do that right off the go, then that's perfectly fine.
No, I just imagine like you could do that.
Yes.
Because it sounds very cumbersome to create the README files in 4 different folders. So if you're lazy, you can just use a full loop. I don't know the syntax, but I suppose you can use it. So that's why I'm just asking, should we just do the lazy, not the lazy, like the more cumbersome method, or just go ahead and just study loop for loop? I don't
So
know.
for this assignment, you can definitely use the lazy method. But for your actual projects, you'll want to create each README file individually, because each of the files in each subdirectory are different. So for example, this README file here could contain content saying figure 1a data.csv was obtained through alignment of certain DNA sequences with human genome, and counts of and statistics of those alignments were reported in these .csv files.
Yeah,
Whereas,
that's clear. Like,
yes,
when you would want to edit the README file, of course, you would have to edit each file by themselves. But when you want to create like README files in like in this graph, I would suppose you could do the script. I suppose, I don't know.
Yes, you can use a script for that.
Okay, thanks.
Yep, happy to help. Any other questions?
Well, I just created the summary data notebook and multi-panel and figure folders. But when I'm trying to introduce the figure 1 data and etc. that in the summary data, right? I want to introduce this files there. It says that it doesn't find summary data in the such file or directory, but I'm looking on the left on my files and I have summary data created. What can be the problem?
So the issue here might be that you're running things in different code blocks. Because as you recall, you want to run if you want to run Unix commands from within a certain directory, then you should do it in the same code block as the change directory command. As for the specifics of your issue, would you like to share your screen, and then we can address it more clearly? Okay, I will stop sharing, and it's ready for you when you need it.
1 second. I had to reopen the Zoom for that because I had to grant it access. Can you accept me back if I?
Yes. Well, actually, yes, I should be able to. Yes, because I'm a co-host.
Okay. So I'm reopening.
Okay.
Mm.
Okay. Hi,
So
welcome back.
Yeah, hi. Can you see my screen?
Yes, we can see your screen.
Okay, so as you can see, I created the folders there in repository. And in the next command line, I try to create all the figures that should be in the first folder in the summary data, and it doesn't find this directory.
Okay, so the reason for this is because you've entered the that summary data folder is inside the repository data folder. So when you run this command, change directory summary data, the Google Colab will look for a folder called summary data within the content directory. However, it can't find it. So first, yes, you need to use the path.
Okay, thanks.
There you go. Yes.
If I run the same command to create these files again, these figures, it doesn't duplicate them, does it?
It does not.
Why not?
Because when you run the touch command, it will create essentially files of the same name, but except because those files already exist, it won't create any new files.
So if I had some information in the already created file, it won't get replaced by a new file with empty information, right?
Not with touch.
Okay.
Touch does a bit of something else, but we'll go over that in the future.
Okay, good. The readmes should be TXT files?
If you want, as long as they are called README. Sometimes they'll have a different extension, like you may find them to be .md, which stands for markdown file. Sometimes you'll also find them with no extension at all, just plain README. So,
Oh, that's possible. Maybe just README without extension.
Yeah, you can.
Yeah, but it will be an executable file and not a text file or a markdown file. So it won't help you in the end.
Excuse me, I didn't get it.
Yeah, so if you don't put an extension to the to the file, then it will become an executable file. I mean, it will not open, or it will not work. So yeah, so it will not help you at the end.
Okay, thanks.
Yeah.
Okay, so once the assignment is done, we are done for today, or
Yeah,
we go to another?
You can leave. You can email either Sergey or us. I'm not sure if you guys have our emails yet.
We do have it because Professor Sergey in the last email added you as a CC. So you actually have all our emails as well.
Okay.
So yeah, that's just now. Okay, thank you so much. Have a great day in whatever you are going to sleep here because it's already too late.
Yeah.
Thank you so much.
Yeah. Good night. Rest well.
Good night. Yeah. Good day. Bye bye.
Bye bye.
Okay. Goodbye. Thank you.
Okay. Thank you for coming.
Thank you. Goodbye.
Goodbye.
Bye.
Have a nice day or evening. Goodbye. Thank you for your help.
Good night.
Have a nice rest of the day. Bye-bye.
Thank
Bye-bye.
you. Thank
Bye-bye.
you. Have a nice day. Bye.
Have a nice day too.
Thank you very much.
Have a nice day.
Thank you for coming.
Excuse me, we'll have these presentations in our mail.
I believe Dr. Mongol said that he would email you all the presentation
Yes.
for module 1. And the link here is in the chat if you can get it to look at this notebook.
Lab.
Yes.
Thank you.
Yep.
Have a nice day.
Have a nice day or night.
Night.
I have a little problem. Let's show you.
No worries, we'll work through it. And yeah, screen share when you're ready.
Yeah, of course. I try to make the homework. I make a directory repository. I go to repository. I make all the repository in all the directory in this repository directory, and then I tried to create files in summary data, but these files was creating somewhere else or not. Oh no, it's okay. It's okay. Why? I don't know, not understand why it appear here also. Do you see it?
Yes, I see it.
I make
Perhaps
it correct
if
or not?
Maybe we can go over the RM command for removing files.
Repeat, please.
Cynthia,
repeat
what
that.
do you think we should explain the RM command for removing those extraneous files?
Yeah, yes. We have the, so in the example assignment 1 notebook, we introduce the remove command, and you can use the remove command to remove those files.
Okay, I can remove it with remove command, yes?
Yes.
The question is, I need to be in the sample data to remove it, or I can remove it being in the another directory?
It looks like those files aren't specifically in sample data. So as long as you're in the content folder, probably in this case though, if you just want to delete it right away without code, hover your cursor, your mouse cursor over the file you want to delete. And yes, you can click delete.
Okay.
Yes, but just for future reference, to remove a file, you have to first enter the repository or the directory that the file is in. So in this case, you would enter the repository file directory first, and then you would remove the files from there.
Or the issue dot here, I think, is that those files actually might not be in the repository folder. They're just in the content folder.
Yeah, it is in content folder.
Oh, all right.
Yep.
Okay, thank you very much. See you tomorrow.
Yeah, thank you for coming. See you tomorrow.
Bye.
Bye-bye. Okay, it's 1 p.m. now. Anyone who's still here and not a TA,
No, it's
there
me
won't be
again.
any-
Have a
Oh.
nice day. I just stayed. Have a nice day.
No worries. Have a nice day too, or night, and rest well.
So
Cynthia, I'm gonna
basically, if you have
have to head out early. I gotta go to class, so
Sure.
I'll catch you.
No worries. Catch you later, Ram.
Yeah.
See you.
So basically, if you have any questions on the assignment, we can email you so you can help us somehow, right?
Yes.
Okay, great, because I don't think I will manage to do the whole assignment right now. Okay, thank you so much. Bye.
Yeah, thank you for coming. Bye.
Cynthia, may I start with a question?
Sure.
So, so I did the last night's assignment, right? And I created every directory and every file in every directory. But when I restart that file, the directories are no longer there in files.
Yes. The reason for that is because because we're using Google's machines, Google does not want a whole bunch of files from all the users of Collaboratory to accumulate over time. And for that reason, they delete the files that people create whenever you close the notebook.
Okay.
So
Okay,
if you want to, if you want to save files, add it to your Google Drive or download them locally.
Mm-hmm. Okay, that makes sense. Thanks.
Yep.
Cynthia, another question.
Sure thing.
Could you please share the script for today?
Yes, I'm about to do that.
Thank you.
Oh, Cynthia, and here's one more thing. I was just thinking if we can have the scripts before the lecture starts. So I was wondering if I should address this to Sergey or you can handle this.
Okay. Yeah. We'll have that starting tomorrow. So before the lecture.
Great.
Okay.
Thanks.
Anyways, here's the link to the notebook for, oh, wait, hold on. I damn that. Here's the link. Yes. Or wait, let me, I got a direct message. Hold on. Okay. Just setting a few things more up. Okay, I'm going to share my screen now. Can everyone see everything?
Yeah.
Yes.
Okay. So for lab 2, we're going to introduce something called Unix scripts. So in lab 1, you got a general idea and familiarity with Unix systems, where instead of like on most laptops and desktop computers these days, where you have a graphical interface to interact with things, with Unix, you use code to do that. And with that code, as we showed yesterday, you can navigate through file systems, like entering folders, leaving folders, creating new folders, and then creating files in those folders. So with Unix scripting here, sometimes you will want to execute multiple Unix commands all at once, and potentially on multiple different files. And so you can combine multiple commands in these script files. And this helps you easily share your code with collaborators. And you can even automate your analyses with it. For example, let's say you have multiple runs where you get samples and you want to run your analyses on the first batch, and then later on you want to run your analyses on the second batch, and so on. In that case, Unix scripts are the way to go. Okay, so before we create the scripts themselves, let's learn some more Unix commands so we can expand what we are able to do in Unix, and in turn, our Unix scripts. So the first Unix command we will cover today is the echo command. And as what the echo command does is that you give it some text that's surrounded by quotation marks, like double quotations or single quotations. And that form where you have words and then within quotations is called a string. And so if you run the echo command with a string as its first command line argument, then it will send that text back out as output. That's why it's called echo. It takes what you give to it and gives it back. This doesn't seem super useful at the moment, but later on in this lab, you'll see how it's quite essential for certain operations. So we can do that here by writing bash. So on this right side, I have an empty notebook, and then we'll write echo and then the string we want. So, and then if we run this code block, then it'll output hello world, which is the same string that we put in. Additionally, you can use multiple command line arguments by giving the echo command multiple strings. For example, you have, again, I have string 1, string 2, string 3. And if we run that, then it'll print out all those strings. Okay, so moving on to another Unix command. So oftentimes in the Unix environment, you want to download certain files to your current working directory. One way to do that is through this bash command called wget or webget, because you're getting files from the internet or the World Wide Web. So here you can type, oh, hey Ram. So here you can type wget, and then it'll use the option O, capital O, and the option itself takes a command line argument. And that argument will be the name of the file you want to save whatever you download. So in this case, we'll call it example.txt. And we'll download it from this direct link. So with these kinds of direct links, you can get from many different places. For example, this link in particular is from Google Drive, but you can also get them off websites that have lots of code, like here's somebody's GitHub page where they've published a paper, and all the files related to their paper. And for example, if you wanted to download one of their specific files, then you could get a link from here, where it says copy link address. And then that would give this link up here. Namely, you should use direct links. And a direct link is a link that if you click on it, it immediately creates a download. So as you notice, when I clicked view raw and I'll click it again, it created a download down here. But yeah, in addition to GitHub, you may have also heard of Zenodo. It's another place where researchers will put will put their files. For example, here's some other paper, and they publicly posted a .csv file and this .ods file. In any case, here's the download button, and you can get the link address, the direct link, and then download it with wget. So then once you've downloaded a file with this command, it'll output a whole bunch of text saying that it downloaded it. And you can verify that it's successfully downloaded in the left-hand panel, where here we have example.txt. Though you can also do that with code, where you just use the list command to just check out what's in the current directory. So here we have example.txt here as well. So this is a lot of text. And let's say you want to download like 10 files. It's going to output something like this for all 10 of those files. And that can be quite messy in your notebook. And so you can add an additional option, this -nv option, or as the long version, --no verbose option, in order to reduce the amount of text that appears when you download a file. So copying that over here, see, it just creates one line to say that it's successfully downloaded, instead of all this stuff up here. If you don't want any text though, you can append this bit of incantation to the end of a command line with wget, and it'll, when you run it, it'll download the file. But let's actually change the name so you can tell that it's downloading a new file. We'll call this one example dupe, because it's a duplicate version of the first example file. And when we run this, it won't give any output, but we can check here with ls that it indeed downloaded. Same over here in the left-hand interface. Any questions so far?
What does the O do? -O?
So the -O is short for output document. So it's an option that you put it after using the wget command, and then you put the name of the file that you want to download. So notice how, oh, go on.
Yeah, no, you go on.
Okay. Notice how the link here in both of these wgets is the same. And it's the same on the left, on this right-hand side as well. But I was able to create two different files, but the contents of the file are the same because they came from the same link. So likewise, I could create a third file called unique name.txt, and it would still just have the same content as whatever this link connects to.
And if you don't specify the -O, then it would be downloaded with the name it was originally made.
I wish it did that, but unfortunately it doesn't. I'll show you right here. It actually gives, for this particular link, just some kind of weird name that's related to the link itself. So here I removed the -o option, and now we have this file called UC ? export equals download blah 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 blah.
Yeah. Okay. Thanks.
Yep. So yeah. Any other questions? Okay. Sounds like we're ready to move on then. So the next command we'll go over is using the cat command. So what you can use the cat command to read files and also concatenate or combine files. So starting off, let's read the file that we just downloaded, example.txt. So we'll create a new code block and type cat example.txt, where example.txt is the name of the file we want to read, and it's the command line argument for cat. Here we can see that the contents of this text file, and it just has a bunch of sentences. And yeah, that's the file. Cat itself is an abbreviation of the word concatenate. And so you can also use it to combine two files together. So here, we're going to download another file called example2.txt from a different link. And after running that, we can read this file with cat. And we can see that the second file has different lines of text. Now then, when we want to combine example1.txt and example2.txt, we will use two command line arguments. The first one being the name of the first file. So this will be the file at the start of the combined file, and then we'll append the text in example2.txt to that. Shown here, you can see that this text over here was combined with this text over here to create this complete block of text. So that's useful because sometimes you'll want to combine files. Let's say you have multiple DNA sequences from similar samples that you want to pool together, then you'd use cat for that. In any case, you'd also want to save the results of cat as its own file. And you can do that with a special operator, this arrow sign. If you run that, so what this does is it outputs the same thing as above and then redirects that output instead of printing it right here to the notebook itself. It'll send it to a new file, which we will call combined example.txt. So this is a completely new file. It does not already exist in our directory. And so when we run this code, we now can see that it created the file right there. And we can read that file by the same way we read the other two files, which is cat and then the name of the file. Like so. So yeah, the next command we're going to introduce is the word count command, or WC. It can be used to count various statistics of the strings that you give it, either a single line string, like we're going to introduce here, or entire files, which we'll show afterwards. So in order to give the WC command a single string, you have to use this pipe symbol here. Because if you try typing like WC, this is a string, so give it a string, it'll just produce an error. Because at this point, it's looking for a file, but this string isn't a file. So instead, we'll use the echo command that we showed before, where we echo some string, in which case this is a string that says this string has 1 line, 12 words, and 70 characters, including spaces. And then we give that to the WC command, and what it'll output are 3 numbers representing in turn the line number of lines, the number of words, and the number of characters, including spaces. All good so far? Okay, yep. Great. So by default, it will give out all 3 statistics at once. However, if you only want a specific one of these, you can use the following command line options, either -L or double dash lines or words or for characters. Though, as a particular note, this uses -M because -C is already taken for something else. And you can do that as follows over here. So we'll run this code on the right side. There it gives the number of lines. There it gives the number of words. And there it gives the number of characters. So to conceptualize what's going on in this whole pipe thing, you can imagine the following, where there's a literal pipe that connects these 2 different commands, the echo command and the word count command. So you'll give the echo command a string, and since the echo command essentially echoes what it's been given, it'll send that down through the pipe and give it to the word count command. And then the word count command will do its own thing and output the default statistics. So that's how piping works, you use it when you want to connect multiple different commands, where you want the input of one command to be the output of another command, and you can create a whole chain of interlinked Unix commands to run your analyses. So yeah, okay. So you can, like I mentioned before, you can also run the word count on files. It's quite simpler to do that. You just use the word count command and then type the name of the file that you want to get statistics for. In this case, combined example.txt has 7 lines, 58 words, and 303 characters. So yeah. Okay, moving on to the next Unix command, we have grep. Grep is a command you can use whenever you need to know whether a file contains a specific word or character. It'll output the lines of the file that contain that specified string. So to use this, you give it at least 2 arguments, in which case here we're going to use combine example.txt again, and we're going to look for all occurrences of the word this in combined example.txt. And so upon running, And so upon running this bit of text, we'll find these 3 lines that have the word this. So here's the word this, here's the word this, and then here's the word this here. So by default, grep is case sensitive. So notice how it didn't output the files that have this with a capital T. So if you want that, you can type, you can use this, you can use a search string that has a capital T instead. However, then these instances with the lowercase this are no longer shown. If you want
out of them, like cat grep this with capital and this with grep with this with no capital.
Yes, we can do that through the ignore case option, -I or --ignore.
I'm sorry for interrupting. Domnul Tudor, vă rog deconectați microfonul. Deconectați microfonul, domnul Tudor.
Da, vă aud.
Da, mulțumesc, mulțumesc. Sorry.
Yeah, no worries. But yeah, so in this case, if we use the -I option, we can then get all lines regardless of capitalization. So yeah, in addition, you can also look for strings based on their relative position in the line. So for example, this upper caret anchor is used to specify lines where the target string is at the beginning of the line. In addition, there's also this $sign anchor, which can be used to represent lines where the target string is at the very end. So if we run this code block right here with this caret sign before the word this, then if you compare that to, hold on, delete. If you compare that to the last time we used this as a string, you can see that one of the lines is actually missing now. That's because with this caret, now it only gives us the lines that where this is the first word at the very beginning of the sentence. Likewise, if we type file and then the $sign anchor, it'll only output lines where file is the very last word. So here, even the situation where it's file and then period, it doesn't include that because the period is a different character. And when you use these strings, as was briefly mentioned in the lecture from the sounds of it, those regular expressions, they have to be exact matches to whatever you specify. So yeah, that's why it only got this line and this line, but not this line, which also ends in file, but has a period. Okay. This whole thing with regular expressions too is where the name of this command, grep, comes from. Since grep is an acronym for Global Regular Expression Print, where it looks for regular expressions and then prints out the lines that match that regular expression. And global is just because like it looks at the entire file. Anyways, now that we have some more Unix commands under our belts, we can then create Unix scripts. So one key distinguishing part of Unix scripts that differentiates them from other kinds of files is that they have this incantation at the start, where it's &, !bin/bash. what this does is it tells most any computer to execute commands that come after this line within a bash shell. If you don't have this and you try to run a file with commands, then the computer might not know what to do with them and how to run them. So it's very important that all your scripts start with this. Anyways, like before, we can use command to create a file, except in this situation, we don't want to concatenate files together. Instead, we just want to create a completely new file. And so we can create our Unix scripts in this manner, where we have cat, and then the redirection operator, and then the name of the file that we want to create. In this case, we're creating my script because it's a Unix script. And then all the lines after that will be saved within my script. So we have this incantation, and then we have echo hello world. If we run that, it'll execute without output, and then we can verify that these lines were saved in my script by using cat again, like we did before. So yeah, this is the content of the My Script file that we just created. However, we can't execute the script right off the bat. The reason
I do have a question.
Okay,
Sorry,
sure.
Cynthia.
Go ahead. What's your question?
So everything that's in the code box below cat big assign my script, it will be concatenated to that file. Anything?
Correct.
So if you want to write another script, you have to get another box, code box.
Yes. So we can create something called like My Script 2, and we can say hello world again. And then when we look at that script, we'll then, wait, My Script 2. We'll then see that it contains different content. You can use this more generally whenever you want to create a file in Unix, a file from scratch, that is.
So why don't we use touch for this?
So the reason why we aren't using touch here is because touch creates an empty file. So if we try something like this, where we have touch my script 3, we can see that it did create a file, my script 3. However, when we go to look at the contents of my script 3, we'll see that the file is empty, that there's nothing in it, and hence it doesn't output.
Can we just add after this with cat to that after we created a touch, or we would have 2 lines instead of 1? That's the idea, I suppose. We have to create with touch and then to concatenate some script into the file.
So that would be possible. What that would do in that situation is that touch would create an empty file, and then if you run something like this, then it would overwrite that file, which is fine in this case because it's an empty file. So
I get it.
Yeah, it would so touch would create a file, and then cat would also try to create a file, but it already exists. But that's fine. So just
a waste of resources, I suppose.
Yes, a very minor one, but yeah. Let's see. So yeah, you can use this generally whenever you want to create files. So let's say in some situation you don't want to you want to make something that's not a Unix script. I don't know. We'll call this like random file, and we can just have a bunch of random text beneath it. And it'll save that in that file. Actually, let's save it under random file.txt. This is meant to be a text file, not an executable file. So then here we can check its contents with cat random file. I mean, we can see that it just has a bunch of nonsense in it, but if I wanted to create a file that was not a Unix script, but has like multiple lines and whatnot, then I could do it this way. So yeah, as I mentioned before, though, these files that I created here, My Script and My Script 2, they aren't immediately executable right off the bat. And by executable, I mean that if you tell the notebook to try and run the script as it is right now, it will be unable to do that. However, we can change that with the chmod, which is to like change modify permissions. Yeah, I don't remember what chmod means, but in terms of like the abbreviation. But anyways, so we'll do that. But first, let's verify that this is indeed the case, that we cannot execute these files. So we can use the list command like we showed before, but with a new option called -l. And that provides a long list, which is why it's L. And here we can see the names of the files like we can before, but we can also see a bunch of information about those files. There's a lot to cover here right now. Some of them may be immediately obvious, like for example, January 13th is when these files were created. And the time they were created is shown here. And then this root stuff describes like who owns the file. Root is just something related to Google Colaboratory. If you run this outside of Google Colaboratory, then the name of your computer account might be here. And then this in the middle right here is how big the file is in terms of bytes. So like ones and zeros. That said, we're not interested in all those details at the moment. What we're interested right now is this column at the very left, which describes file permissions. For example, if you share a computer with other researchers, you don't want them to accidentally mess up your files, right? So you'll have your files set to where only you can modify your files. That's also important for security reasons. Sometimes, let's say, you don't want someone deleting your files, then you can prevent that through this to an extent. In any case, though, here we will verify that my script is non-executable by looking at this particular slot right here, where it's a dash, which means it's not executable. If it were executable, then we'd see an X here, since X is an abbreviation for executable. So in order to change this into an X, we'll use the command, the chmod command. And the first argument is u plus X, and that represents that us, the user, we want to give execution permissions to ourselves for this specific file here called My Script. So then if we run this code block and then recheck, then we'll see that now My Script now has an X right there. So right there.
Okay, so R stands for reading, W stands for writing, X stands for executable. What does D stands for?
So D stands for directory. So all these files are like text files, and then here's our executable file, but this one's a directory. It's like,
so I got it.
Yeah,
Okay.
yeah, it marks folders. But yeah, it's this left column that describes the permissions for ourselves, and then the second column, the second group of three, describes permissions for people within a specified group. So like maybe you'd allow certain trusted individuals to modify your files or to run your files. And that would be reflected in the second column. And then this third column here is just the public permissions. So if you have RWX here, that means anyone can run, can read, can write, or execute your file.
Isn't that kind of security as the security issue if someone has X? Like I could like connect to a computer and just have access to those files, reading those files.
Yeah, that's why by default you see in this situation there's dashes in this over here to show that public users can read the files, but they can't.
Even reading the files isn't a security issue.
Potentially, you could remove that for. Let me do that for my
suppose
script right here.
by default is the public can read the files when you create it.
Yes, on Google Colab. It will depend on what operating system you're using. For example, on your own university computer, if they might have it set up differently for security reasons.
Okay, got it.
Yep.
And is it possible to have everywhere minuses even without R? No read, no write, no execute.
Yes. For example, let me do that right now with let's say, all right, okay. So instead of +X, where we're giving ourselves permissions, let's say I'll give. Oh, okay. I'll just do it individually. And creating there. Okay. So what I did here is I put an A where instead of U for user, as in yourself, A stands for all. So user, the group that you trust, and then the public, everyone. And as you can see, it's made all of them dashes, though not the right one. Let's see if we can. Oh yeah, let me run that. Okay, yes. So as you'll see here, now all of them are just dashes. So yes, yeah.
What would be the point?
Not much, but it is possible.
Okay.
Like maybe if you for archiving a file, I guess, where you don't want to accidentally modify the file yourself, and you don't want anyone in your group to modify it, and then you also don't want obviously public people to modify it.
Yeah, but you could leave it just the R one where to read it, and you won't be able to edit it, won't be able to execute it. So in this way, you cannot even read it, write, execute. So it's like, I don't know, it's like a hidden file in Windows.
Something like that. There's a different syntax for hidden files in Unix, but do you want to hear about it right now? I could show you real quick.
I don't think it's necessary. I mean, we can Google it. It's not relevant to our colleagues, so I don't want to spend their time.
Gotcha. But yeah, it is possible, and you can practice changing the permissions yourselves with the chmod command. But yeah, once we've done that, we can now move on to executing our script. And the way we'll do that is with this / prefix, where the dot represents the current directory. You can use the dot well, in the last lecture, you may have heard that it was mentioned that you can move to the directory above the current directory with double dot, while just having a single dot represents the current directory. And by using this prefix, you're saying that I want to run this file, my script, that's in the current directory. And when you run this file, it says hello world because that's what was stored in the file. You can also use the absolute path as was described in the previous lab, where you use the entire path. So from root to content to this script in the content folder. And I'll do the same thing. But if you're already in the folder, then just the / prefix is enough. Since and that itself is called the relative path because it's relative to where the current working directory is. But yeah, so in addition to these things, we'll introduce a couple special symbols and words in Unix to help you with the assignments. So far you've been introduced to a bunch of different symbols. So the redirection operator, caret, single caret, the piping operator, and then the regular expression anchors, the upper caret, and then the $sign. Here we'll introduce double arrow, the Unix wildcard symbol, which is an asterisk, and the $sign again, but instead this time as a variable prefix, and a syntax for for loops. So starting off with that first one, as described before, the single caret will overwrite a file if it already exists. That can potentially be dangerous in the case where you have a file with your results, and then let's say you were just testing something out and accidentally use this operator to overwrite that existing file. Then now your results are like replaced with whatever you're testing out. So in situations where you only want to append text to an existing file, you'll use this double arrow instead. So let's practice this with the practice text file. We'll call it append practice.txt. It's and within this file, we'll have one line of text that says this file has one line. So if we run this and then check out what's in the file, it'll just show that single line. Yep, this file has one line. Then if we want to add another line to it, we can run this where where everything beneath this command will be added to the append practice.txt. Oh, I typoed. Append to append. But yeah, if we run this, and then check the status of the file, we'll see that now this file has 2 lines. And yeah, that's how you append new lines to a file without overwriting it. Okay, so this next series of commands you'll find use for it when you have multiple files that you want to run a bunch of, let's say, either scripts or just regular Unix commands on. This is often the case because online data sets that you download will often comprise of multiple files, or maybe your collaborators will send you multiple files and you want to analyze all the files together. So you'll use what's called a for loop. The reason why it's called a loop is because you loop over every single file. You iterate. Let's say you have 3 files, you'll do actions on the first file, then you'll do stuff on the second file, and then do the same stuff on the third file. And so we'll practice this by first creating 3 empty files just to get practice with this. As you'll see, there's example.txt, example2.txt, and example3.txt right there. And then here we'll have this structure of the for loop, where you'll say for, and then you'll write file in, and then asterisk, and then the file extension, then a semicolon, then you'll write do, and then you'll write whatever you want to do repeatedly in the middle. And then once you're done with that, you close it. You close the for loop with the word done. So in this case, what we want to do is for every file that's a .txt file, we'll print text file found. So if we run this, we'll see that we have, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9 files, 9 text files in all these files that we've accumulated so far. Let's say we want to have the name of the files, then we'll use this echo and then $ and file. And what this means is, so because in this first line, we wrote for file in asterisk text. What that means is that every time that bash finds a match, a file that ends in .txt, and it doesn't matter what's before it, it can be anything, and that's what this wildcard represents, then we'll save that in what's called a variable. And the name of this variable is file. So you can think of it like a variable, like a box in this case, where whenever bash finds a text file, it'll put it in the box. And then we'll run these commands on whatever's in the box. Then we'll remove whatever's in the box and then look for the next text file and then put that in the box and then run the commands on that. So in this case, if we run this, we'll see that we found a text file and we put it in the box, and the name of this file was append practice.txt. And the commands that we run once we have append practice.txt is we print text file found, and then we say the name of the variable, name append practice.txt, name, yeah. And this $ allows you to access this variable file, so access the contents of the box. If you remove the $, you'll get an error, because then here now it thinks that you want to repeat the word file, and that's not what we want. We want specifically what's in this box called file. So yeah, any questions about this?
Yeah, I do. I've tried this this for loop script. I don't have any txt files, and I thought that there won't be any echoes, but I actually got an echo.
Did you have the asterisks?
Yes.
Okay, so the asterisk, because it doesn't end in .text, it'll look for any file. So, for example, if we do this,
but I got the asterisk and then .txt. So I thought that we will find only files with yeah, like this.
Like this.
Yeah, like can yeah.
Okay.
And
then yeah. Want me to?
I can share my screen. I don't know.
Yes. Okay, it's red. Wait, let me double check. You have permissions?
No.
Okay, it says all participants can share. So try again.
Yep, I can.
Oh,
Yeah, I can.
Oh, you can.
Yeah.
Okay, great.
Yeah, you can see it. I'm not sure. Can you see my screen?
Yeah, we can see it.
Yeah. So right now I don't have any txt files in content. Like, yeah. And if I run the script, I still got this. I thought it would not enter the loop. That's why I just thought I would skip the loop and wouldn't have any output. Maybe something like Google Collaborators. I don't know. I don't know.
Yeah.
It's a weird. I don't know. Like if I would add, I don't know, here something like one.
The code looks right. For file.
Something you can try is on the left-hand navigation panel. Try clicking the refresh button.
Yeah, I did it.
Oh, okay.
So, yeah, nothing is here.
If there's a,
okay.
Yeah.
I can just try to.
Could you check with, yeah, could you do that? I mean, just to check and see, maybe just the directory is wrong?
Do you want me to?
Are all your text files in the sample data?
The sample data is just everything what's on like Google. This is like by default.
Yeah, okay. And then where did you create your text, like the example text files like that Cynthia was showing?
No, I remove them.
Oh, you removed them. Okay.
Yeah, just if I create them, and when I run the script, yeah, they're here, and of course, yeah, it makes sense. But if I remove them, then they're not here, and I run the script, it shows me the output. That's
guess that's just how it works.
Yeah.
Yeah.
Okay.
But yeah, thanks for bringing that up.
Yeah, I don't know.
If
just
for some reason you want if you don't want that for loop to be run, then you could encapsulate that in a different kind of statement. Yeah, an if.
Yeah, I'm not too familiar with Unix, so I thought like Python, if I suppose if you would write something like that, it just won't run the loop.
Yeah.
I mean, yeah. But yeah.
Yep. But yeah, okay. I'm gonna continue sharing my screen. Anyways, now that we've covered all those things, any other questions before we move on to the assignment?
You just mentioned NF. What does it do?
The if statement that is that what you said?
Oh, I thought you said NF. Okay, never mind. Yeah, I got it.
Okay. Okay. Anyone else? Okay. So for lab assignment 2, we'll be parsing FASTA files with Unix scripts. And what FASTA files are that they're a format of file that is often used to store nucleotide and amino acid sequence data. FASTA files will have the extension .fasta or .fa, and each entry in a FASTA format will have 2 parts, a header and a sequence. The header lines can be used to record basically anything you want or anything the person who wrote the file wants. These can include sequence accession numbers, what organism the sequence came from, the gene name, if it's a gene, for example, or loci indices, as in where in a genome the sequence comes from, but again, just anything. However, they all have one thing in common. They fit within a single line, and the line begins with this arrow symbol. Then after that, there'll be a FASTA sequence that's stored after the respective headers, and they can be as long as you want, or they can be just like one line too. Below is an example of a FASTA entry. So yeah, as you see, here's the arrow symbol and the header with different information about the sequence, and then the sequence itself. And as you see here, they can be different too. As in this header is quite different from this header. So again, headers can basically be anything as long as they have this arrow symbol. Okay, so for this assignment, in a copy of this Colab notebook, use the comments presented in commands presented in the previous sections to write a Unix script to complete the exercises below. We'll grade the exercises based on whether you can produce correct output files that match the specifications. To start, download these files below with webget. So you can just copy and run this code. That way, all the files that you download have the correct names and yeah. Then once you have these files, there are 2 exercises. First, create a Unix script named header extractor, and to extract the FASTA headers from all files and save them in a new file called headers.txt. Let's say in this example, you're more interested in what's stored in the headers, as in where the sequences come from, than what the sequences are themselves. So that'd be a situation where you do something like this. Then for the second exercise, create a Unix script named seq measurer to extract both the headers and the sequences from all files and save them in a file called lengths.txt, except instead of the sequences themselves, you have the sequence lengths. And the format of this lengths.txt files should be as follows, where it'll be like a typical FASTA file, but instead of the sequence, you'll have the length of that sequence. So the number of nucleotides. And yeah, those are the 2 exercises for today. Any questions before you all start?
Repeat, Cynthia, repeat this again. What do you mean headers? You mean the first 10 units, or you mean the first row?
the lines that have this arrow mark. So go on.
Yeah, I understand. You are not interested in all variables, all information. You are interested only in the first column. You can say like this.
The first row, yeah. The first row, yeah. Whatever has that greater than sign, that means that's the header. This, like, sometimes it'll drag off into the next line just because of just like formatting, but it's whatever has that greater than sign. That is the header for a FASTA file. And there'll be multiple headers within one FASTA file. So she just wants you to grab from one task. She just wants you to grab just that one line from the multiple headers within that one FASTA file. Does that make sense?
Okay, thank you.
Yep.
Thank
And
you.
then you'll combine the headers from all the files that you've downloaded into a new file called headers.txt. Any other questions? Okay, sounds like we're good for now. Good luck, everyone. Me and Ram will be here in case you have any more questions as you go through the exercises.
Yeah, and just like this, like if you're not really sure where to start on this, think back to what we've done in this lab. Like that's what the point of this lab exercise is. It's going to be using what we just went over in this lab. So just think back to like what we're trying to do, what you can do with what we taught in this lab.
I have a question. I download these files and I found that in one file there are a lot of headers.
we put all the headers from all the files in the one file, headers.txt, yes?
Yes.
Yes.
Thank you.
So I'm not sure if I done it correctly. Like, I mean, the first exercise I've done it, but I'm not sure if that's the way I'm supposed to do it. So I Googled it and I found it had will remove just the head, and -1 with a parameter -1 will remove a head. Is it okay? I mean, as far as I know, I'm not a programmer, so I'm not sure, but as far as I know, in programming, is the way you reach your end result doesn't really matter. So I should have we're only supposed to use the tools that you gave us without Google.
So let me get this right. You Googled
how would I remove like the first line of a file? And
okay.
So it got head. So I just wrote the for loop, remove a head, and I concatenate it to the headers file. But
okay.
were I supposed to use head, or is it okay if I used head? If you would, I'm not sure if you grade this, but if you would grade this, would you? It would be okay, or I would be penalized for that.
As long it would be okay as long as you get the correct answers. Though I'd have to see the specific implementation for me to like to make sure that it does indeed create the right files. Because if the head command itself will just show the beginning of a file, whereas here you want all of the fast headers, and not all the fast headers are at the beginning of the file. But yeah, if you can arrive at the end result, then that's fine. That's the assignment right there.
Oh, sorry, I was on mute. I was speaking with myself then.
Yeah, no worries.
In this case, the headers are just at the beginning of a file, all these three files, the FASTA files. So the headers are supposed to be at the first line, right? In all files, in any file.
No,
That's why they're called head.
There's multiple within each file. So if you do like a quick cat or like a head, like the first couple lines, you'll see there's multiple greater than signs. So that's each greater than sign is one header.
Oh, I see
Yeah.
it. Now I see it. So I thought like the header is just supposed to be the first line of the file, but in this case, it's a little bit more complicated. Okay.
Nope.
So in this, yeah. Oh, go ahead, Sophie. Go ahead.
Yeah, like the example here, this could be stored in its own file, and it would have two FASTA entries with two headers. And so if this were one of the files that you'd use for this exercise, then you'd want what's stored in headers.txt to contain both this first header, which is the first line,
I got it.
but then also the
I got
second.
it. So I suppose I have to write this vertical bar and just to find these lines and just those. I suppose like something like that. Okay, thanks. Sorry.
Yeah, happy to help.
I have a question.
Sure thing.
Can I show the screen and to ask this question?
How do you want to do this, Ram? Do you want to move this person to a breakout room?
In which way? What is my thinking? So I create cycle 4, and in this cycle 4, I mentioned that I want to check all the files that have. Just a second.
I think it's fine. Just keep them just in the main room. I mean, it's not like we're showing anything really on the screen. So.
Gotcha. I thought he was going to ask to screen share in a second, in which case that's, I mean, collaboration among students is good though. Then, yeah.
Sorry. So I create cycle 4 and I check all the files and I cat in file headers txt the rows that are determined by the function grep that have the sign more than. But after that,
Okay,
so I cannot understand why I cannot see the headers txt file finally. That's why. Can I show maybe I did in this instrument this cycle for the first time. In the classical Python, it looks like in another way. That's why I'm a little bit confused. So can I show the screen?
Yeah, share your screen. Cynthia, does he have permissions to, or?
Yeah, I just have to stop screen sharing myself.
Yeah.
Can you see?
Yes. Okay.
So I save this information in this script. Yes. I check each file that have this characteristic, and I ask him to add in this file the lines that start with this. What is my mistake?
Okay, so the logic is a little bit off, I think. So if I'm understanding this correctly, you're using cat to create the header extractor script, and then you're trying to run the for loop, right? Is that what you're trying to do?
So could you speak a little bit slowly?
Yeah, sorry.
Because of the echo, I cannot understand everything.
Okay, so let's see. Okay, so you're selecting.
Could I go in? Okay. So remember that the goal of this assignment is to be able to create Unix scripts and then be able to run those scripts just to be able to run those scripts. And so what you have in this code block, this first line where you have cat and then greater than and then header extractor, that will take all the lines below and put them in the header extractor file. It will not run the code below it. Additionally, in that code itself, you'll need to use the $sign where it says file for your grep command, because remember in the example I showed earlier, if you want to access a variable, in this case, the box that contains the FASTA file, you want to put the $sign before the word file to specify that box. Otherwise, grep will look for something called file that doesn't exist.
So like this?
Yes, just like that. Okay, and that created a file. If you look at the material in the lab, you'll want to go over the part where you run the Unix script that you just created.
Header extractor.
Yes, that is the file. You'll want to run that file as an executable file.
Okay, thank you.
Okay, let me know if you have any more questions.
Can I check the first task if it's done correctly?
Sure thing.
Yep.
Okay, so do you see the screen?
Yeah.
Yes.
Okay, so I'm deleting the headers txt now. And I created this head extractor script. Then I gave it a permission to be executable. And I execute it. And now I check what's in the headers txt. And this is the result.
Yep, that is correct.
That's how you do it.
Okay.
Do note that if for example, oh yeah, okay.
I use it the for loop.
Yes.
Yeah, that's another
that
way of
works as
doing it.
well.
Okay.
The reason why the for loop was introduced was, for example, instead of 3 files that we have you download, let's say you were downloading hundreds of files, then you wouldn't want to write grep and then have each of those file names as a command line argument.
Okay.
Yep. But yeah, that is the first part complete.
Okay. Okay, I think I finished it.
Okay, great.
The third part, the second part. I have for every FASTA format, I have the number of field types.
Can you share? We can't see what you're trying to show. Right?
Okay. Yeah.
Yeah.
Okay.
Yeah.
Okay.
Yeah.
have a question.
Sure thing.
So I just noticed that in the header there is already the number of nucleotides there. Should we use those or should we count those?
In this case, we have we're combining all the number of nucleotides across all the FASTA entries in a single file. So if you want to take that value and then add them all together, though that wasn't introduced in this lab, you could do that. But otherwise, there's another way to do it.
Okay, thanks.
It's only me left. Is it only me left and you guys?
No, it looks like there's still a lot of people here.
Oh,
Yeah.
they're not shown to me.
Sorry, can I bother you once again?
Go ahead.
So try to write it, but I don't. The logic seems okay, but I don't get the last end result.
Would you like to screen share?
Yeah.
Okay.
So this. Yeah, I suppose you can see my screen, right?
Yes.
So this is the script. So when I run it, okay, yeah, I run it. I change here the executable, and when I open it, I do get all the characters. Also, all the like word count. Also, I only want the chars characters number.
Right.
So I don't know why it takes everything and just ignore this. It looks to me like ignores everything. And I'm not sure if I.
And this is the latest version of the script that you ran?
Oh no. Oh, okay. Now I see it. Yeah.
Yeah. Since it appended it to the file.
Yeah. So yeah, now I get it. Okay, sorry. I hate Zoom. So once we are over with this, do we have any other assignments?
Not for today. Tomorrow there will be, and every other day of the lab. But for now, you're good to go.
Yeah, okay. Thanks for helping us. Have a good day.
Have a good day. As a hint for everyone else, you'll if you're able to see the screen share, you can use an option for grep called -v in order to get the inverse of a grep result. I'll put it in chat, but you can use this option, and that'll help you complete this assignment.
Sorry, Cynthia. If I finish it, I can leave the chat.
Yes.
Okay.
You're
Thank you.
good to go for today.
Thank you very much.
Yeah, thank you for coming.
Bye.
Bye-bye.
Oh, Cynthia.
Yes.
I just saw that I'm still connected on my iPad. We talked with Professor Sergey about one thing regarding Zoom. And he said to write you an email, maybe you know how to do it. Like every time when we connect, we need to be accepted by the host. So I'm not sure how to solve this, but it would be probably for everyone would be much more easy because we are disconnecting from one device and when connecting to another device, or maybe there is a internet problem. So every time when we connect, you should accept us. I'm not sure how to solve this because I don't use Zoom too much, but maybe it's solvable.
Maybe.
We have experience with Google Meet, and usually I told the Professor Sergey about that. When we create an event in Google Meet and we invite by emails, they already accepted, so they just join automatically. Maybe it's the same thing in Zoom. I'm not sure. But yeah, it would be easier.
Yeah, we'll have to look into that.
Okay, thanks. Have a nice day. Bye.
Yeah, thanks. Have a nice day.
For task number 2, is allowed to create a new file, auxiliary one, or not?
What do you mean by new file specifically?
I would like to put in one file only sequences. I have a file with headers and I have a file with sequences. And then I will unite it.
You can do that. As long as you, at the end, have a file called lengths.txt and also have a script called seek measure.
Thank you very much. And okay, I'll try it. Thank you.
Yeah, good luck.
Okay, can you check my
Sure thing.
what? Thanks. I'll share in a second. So I spent more time to figure out the for command and take a look if it's right.
If you already have the links file, it's just going to append it to the end with your current code.
All right.
If it already existed, yeah.
I'll do it again. Are the numbers right?
I think so, right, Cynthia?
Yeah, I think so too.
Okay, thanks.
Yeah. Congrats, you finished.
Yep, thanks a lot for the lesson and see you tomorrow.
Well, you'll see Ram tomorrow, I think. No, you'll have two different TAs tomorrow,
Okay,
but
okay.
see you some other time in the course.
Yep. Have a nice rest of the day.
Yeah. Good night. Sleep well.
Thanks.
Oh yeah, neither of us are scheduled for tomorrow, right?
Yeah, it's Aditya and Dati.
Okay.
And then there's a couple blank slots left next week, but we have time to fill this out.
Okay, cool.
Yep.
Almost done.
As a reminder for everyone else, no need to rush. Like we are going to end at 1 p.m., but that's not a deadline for this assignment. So you can have more time to think about it, and me and the other TAs will join the Slack channel later, and we can help you there as well outside of class. So yeah, just try your best, and yeah, no need to stress about this, even though it's like one is approaching.
So, excuse me, so we can continue tomorrow to this task to finish?
Yes, like if it's late and you're really tired and you want to go to bed, then you can, go get some rest. But yeah, so we will grade this eventually, like there will eventually be a deadline, but it'll be a deadline for all the assignments. And by then we'll double check to make sure all your assignments are good. And if they are, then you get a certificate for the course for completing it. The assignments and the final project, which I'm not sure how much Sergey has mentioned about it yet, but after the lectures, there will be individual project for all of you.
Okay, thank you.
Cynthia, how we are supposed to submit the assignment, and is there any channel to do this, and how do you expect us to do this?
You can. Did you got this, Ram? Or anyway, you can email us TAs. Well, we're considering making a folder for it later, in which students will have individual folders with their names.
All right.
And then you can put that in your folder, but it's still pretty early in the course. So we're some people may want to continue with the course. Some people might not. Maybe someone will join in. So yeah.
I see. All right.
Yeah.
Thank you. And we can actually reach out to you anytime, and just I know this is going to be a little bit frustrating for you guys. Just want to make sure that communication is smooth, and also I'm sure that
email us. Don't worry about that.
Yeah.
Okay. Because I'm sure that sooner or later our questions, at least mine, are going to be extremely, for the first time, dumb.
Yeah, no,
I know this is the process.
Yeah,
because otherwise
it's a process learning anything.
Both of us started out like this eventually at some point or another, so it's not. Everyone goes through this. It's fine.
Yeah.
Yeah. Feel free to email us with any questions. We'll respond as soon as we can.
Okay. So okay. Got it. Thanks a lot.
Yeah.
Have a great day, guys.
Yeah.
It was nice.
Have a good night.
Yeah. Cheers. Bye.
Cheers.
Bye. Oh, Cynthia, I'm going to upload the video, the recording afterwards.
Yes. Well, okay. So because Sergey changed host to me, we'll have to see how that works. Hopefully, Zoom will be cooperative.
Okay. And the PDF is on his side, so he's gonna upload the PDF of the lecture.
The lecture is still module 1, and that's currently already uploaded.
Yeah, and the second one?
Yes, that'll be uploaded soon.
Good. Thanks a lot.
Before the next one. Yeah, thanks.
Thanks a lot. Really appreciate it, guys.
Thank you very much for your job. Bye-bye.
Yeah, thank you for coming too, and good night.
Can I ask a question? I'm trying to do this, but I seem to have some errors. Can I share my screen?
That's okay. Go ahead. Yeah. We'll figure it out.
Just a second. So in my case, I seem to get this kind of error. It says that the syntax error is near expected to, and token is done, or something like that. And in my results, it's a little bit different from what the other guys had as a result. I think it's because I didn't use like them to do this for all the FA files.
Try removing the word done at the end. Done is specifically part of the for loop structure. So if you don't have a for loop, it will confuse the Unix machine that Google has.
Okay, let me try again. So the result is kind of the same.
Okay, so what
okay, yeah, go ahead, Sophia.
It's okay, right?
At the moment, the reason why it's different from the other people that showed is because they separated out the number of nucleotides per FASTA file based on, they separated per file. Whereas here you're counting all the nucleotides from all the files.
Oh, I see, I see. So
Yes.
it's the sum here. Okay,
Yeah.
because I see it's a higher number than in those cases. I got it.
You'll want the individual numbers.
I see, I see.
So,
okay.
Yep.
Then I'll modify it, and I think I'll do it tomorrow.
Okay.
So we'll be late here. Thank you very much for your help. And,
Yeah.
for
Happy to help.
Class.
Thank you for coming again.
Have a nice day.
Have a nice night to yourself. Bye-bye.
Thank you. Thank you. Bye-bye.